Hello children, today we will learn about quadratic equations class 10. Quadratic equations. Before learning something new, let's quickly revise what we already know about quadratic equations. In the standard form, the quadratic equation is ax squared plus bx plus c equals to 0, where a, b, c are real numbers and a is not equal to 0. Let's understand it through an example. Consider the quadratic equation x squared plus 5x plus 6 equals to 0. Yes children, do remember, in a quadratic equation, the right hand side is always equal to 0. Here you notice that a is 1, which is the coefficient of x squared, b is 5, which is the coefficient of x, and c is 6, which is the constant term. After this lesson, you all will be able to define the roots of a quadratic equation. All of you will be able to solve quadratic equations using factorization, and also you all will be able to relate quadratic equations to day-to-day life. Okay, now we start with solution of a quadratic equation. But what is the meaning of solution? A real number is called a solution or a root of a quadratic equation if it satisfies the equation. Well students, we will understand the meaning of the word root using an example. Consider x squared equals to 4. Yes, it is a quadratic equation, but we will first write it in the standard form by transposing 4 to the left hand side. So we have the equation as x squared minus 4 equals to 0. If you note the two values of x equals to 2 and x equals to minus 2, they both satisfy the equation. So what we say is x equals to 2 and x equals to minus 2, they are the roots of the above equation. Now we will learn how to solve quadratic equation using factorization. Yes, if you remember, factorization was writing a polynomial as product of its factors. So we will use the same concept in finding the root of a quadratic equation. We start with an example. As you can see on the slide, x squared minus 6x equals to 0. Yes, it is a quadratic equation. In order to factorize it, I observe that x is common to both the terms. So I take x common and I am left with x minus 6 in the bracket. Now here, if you observe, we have x into x minus 6 equals to 0. When the product of two numbers is 0, then one of them has to be 0. This is the property of 0 which you have already done. So we use the same property and we say x is 0 or x minus 6 is 0. And from this we get the two roots of the above equation as x equals to 0 or x equals to 6. Let's see another example on factorization of quadratic equation. Consider x squared minus 4 equals to 0. Yes, if you notice, it resembles a squared minus b squared. So we use that identity to factorize the polynomial. Hence, we have on the left hand side x plus 2 into x minus 2 equals to 0. Now once again, the property of 0, if product of two numbers is 0, then one of them has to be 0. So what do we get? We get x plus 2 equals to 0 or x minus 2 equals to 0. Further solving it, x is minus 2 or x equals to 2, and hence the two roots of the quadratic equation. And now coming next is splitting the middle term, which is a very important method for factorization of a quadratic polynomial. Find the roots of quadratic equation 6x squared minus x minus 2 equals to 0. We observe no identity is applicable in factorizing the polynomial. So now we move on to splitting the middle term method. But before that, do ensure your quadratic equation it is written in the standard form. Wow, here it is already in the standard form. Now, in order to split up the middle term, I have to find two numbers such that the sum is -1, which is b, and the product is a into c, that is -2 into 6 -12. So, are you able to get two numbers whose sum is -1 and the product is -12? Very good, right. The numbers are -4 and 3. So, you can see that the middle term minus x I have split up into -4x plus 3x. And then, taking common from the first and the second term and from the third and the fourth term, I finally am able to factorize the quadratic polynomial as 2x plus 1 into 3x minus 2 equals to 0. Yes, my right hand side for quadratic equation. And since product of two numbers or two terms is 0 would imply one of them is 0, hence 2x plus 1 is 0 or 3x minus 2 is 0. So which gives me the two roots of the equation as -1/2 or 2/3. Well, we do one more example to understand factorization of quadratic equations. Consider x squared minus 3x minus 10 equals to 0. No identity is applicable. I cannot take any common factor. So I have to move on with the method of splitting the middle term. But I must ensure the quadratic equation it is in the standard form. Wow, it is already in the standard form. So for splitting the middle term, I need to look for two numbers such that their sum is -3 and the product is -10. So are you able to guess the two numbers? Yes, very right, there are 2 and -5. So I split up the middle term -3x as 2x minus 5x. And then follow the same procedure and I get x minus 5 into x plus 2 equals to 0, which would imply x minus 5 is 0 or x plus 2 is 0. And solving it further, I get two roots of the equation as 5 and -2. Well, now we will learn the application of quadratic equations in day-to-day life. The question is, the area of a rectangular plot is 528 square meters. The length of the plot is 1 more than twice its breadth. We need to find the length and breadth of the plot. These kind of word problems we can solve easily using quadratic equations. Let's see how. We begin with, let the breadth of the plot be x. As per the given condition, we find the length will be 2x plus 1 because the length is 1 more than twice the breadth. Now, recall the formula for area of a rectangle, which is length into breadth. So the area is given to us as 528 and we also know the length and the breadth in terms of x. When we solve this equation and transpose all the terms on the left hand side, I get a quadratic equation as 2x squared plus x minus 528 equals to 0. Now, as you have learned the method of factorization, I follow the same and I am able to solve the equation by getting the two roots of the equation as 16 and -33/2. But I reject -33/2 because the breadth of a rectangular plot, it cannot be a negative number. So I am here with my answer. The breadth of the rectangular plot is 16 meters and therefore the length will be 33 meters. Well, we do one more word problem. Rohan's mother is 26 years older than him. The product of their ages in years 3 years from now will be 360. Find Rohan's present age. These kind of word problems can be easily solved using quadratic equations. Let's see how. We begin with, let Rohan's present age be x years. Therefore, the mother's present age will be x plus 26 years. After 3 years, Rohan's age will be x plus 3, whereas mother's age will be x plus 29. Also, according to the given condition, the product of their ages 3 years from now will be 360. Hence, we have x plus 3 into x plus 29 equals to 360. When we open the bracket, we get x squared plus 29x plus 3x plus 87 equals to 360. Now children, please note here, we have a quadratic equation, but it is not in the standard form. So to bring it in the standard form, we need to transpose 360 to the left hand side. So the quadratic equation which we have will be x squared plus 32x minus 273 equals to 0. Now we will be splitting the middle term and factorizing it in order to find the solution. So you have to look for two numbers such that their sum is 32 and the product is minus 273. Yes, the numbers are quite big. So how do I find out the two numbers? Well, for this you can do the prime factorization of the number 273 and look for two numbers which satisfy the condition. And hence we get the two numbers as 39 and minus 7. So after splitting the middle term and solving the quadratic equation, we get the two roots as minus 39 and 7. But we reject minus 39 since the age cannot be negative. So we are ready with our answer. Rohan's present age is 7 years. Have a look at one more word problem which can be solved using quadratic equations. So, this was all about solving a quadratic equation using factorization. Thank you for watching the presentation.